Hydrogen peroxide is typically regarded as an environmentally friendly alternative to chlorine for water purification and wastewater treatment. Hydrogen peroxide readily decomposes in the presence of heat, light, and catalysts. The quality of a hydrogen peroxide solution must be regularly checked to ensure its effectiveness. The concentration of hydrogen peroxide can be analyzed by an oxidation reduction titration with potassium permanganate. So that is the goal of this lab, to determine the concentration of the hydrogen peroxide sample that I'm going to give you. So just as background, titration is a method of volumetric analysis, the use of volume measurements to analyze the concentration of an unknown. The most common types of titrations are acid-base titrations, which we'll be doing a little bit later on in the semester, in which an acid, for example, is analyzed by measuring the amount of standard base solution required to neutralize a known amount of acid. A similar principle applies to oxidation reduction reactions. If a solution contains a substance that can be oxidized, then the concentration of that substance can be analyzed by titrating it with a standard solution of a strong oxidizing agent. So a standard solution is a solution whose concentration we know. Potassium permanganate, KMnO4, is a common oxidizing agent used as a titrant in redox titrations. In an acidic solution, the permanganate ion is reduced according to the following unbalanced half reaction. So you got that there for you. So the first titration we're going to do is figuring out the concentration of the potassium permanganate. All right, because we're going to be using that to determine the concentration of hydrogen peroxide, but in order to do that, we need to know the concentration of potassium permanganate. We do not know the concentration of potassium permanganate, and in order to determine the concentration of hydrogen peroxide, we must find this. In order to accurately determine the concentration of a potassium permanganate solution, it may be titrated against a solution containing a known concentration of iron ions. Ferrous ammonium sulfate serves as a primary standard to titrate the unknown potassium permanganate solution. In the corresponding half reaction, the iron ion is oxidized to iron 3+. For this redox titration, the equivalence point occurs when the exact number of moles of permanganate ions has been added to react completely with the iron 2 ions in the solution of the primary standard. The indicator for this titration is the permanganate ion itself. The permanganate ion is purple in solution, and its reduction product, the manganese ion, is almost colorless. At the end point of the titration, meaning when you've passed your equivalence point, the solution changes from colorless to light pink, as the last drop of permanganate added does not react and keeps its color. So what this is telling you is you're going to be adding permanganate to iron 2 ions. Now, the permanganate is going to react with the iron, producing manganese ions and iron ions, and those are going to be colorless. Once you have equal amounts of the iron 2 ions and the permanganate, that is your equivalence point. As soon as you pass that, just one extra drop of permanganate, then you're going to see a purple color, and you know you've just passed your equivalence point, and you can assume you're at your equivalence point. The second titration we're going to do is standardizing the hydrogen peroxide to determine the concentration, which is the goal of this lab. A solution of hydrogen peroxide will be titrated with a standard potassium permanganate solution to determine the hydrogen peroxide concentration. The end point occurs when the pink color of the permanganate ion persists. The unbalanced half reaction is shown below. So the first thing I need you to do is to balance the oxidation and reduction half reactions for the iron 2 ions and the permanganate ion, and then write a balanced chemical equation for the overall reaction that occurs. Okay? And then once you're done, I need you to answer this question. For the titration of permanganate and iron ions, what is true about the equivalence point? So here are some quick safety precautions. Sulfuric acid is corrosive to eyes, skin, and other tissue. Always add acid to water, never the reverse. Notify your teacher and clean up all acid spills immediately. Dilute potassium permanganate solution. It is a skin and eye irritant and strong stain. It will stain skin and clothing. Avoid contact of all chemicals with eyes and skin. Wear goggles and gloves and an apron, which I can provide. Wash hands thoroughly with soap and water before leaving the laboratory. Okay? So the first thing I need you to do is to read the entire introductory activity, and then you're going to create a data table. I'm going to take you through this first activity, this first determining the concentration of potassium permanganate take you through the steps, and then you will actually do it in the lab. So in this video, I'm going to take you through all the steps that you need in order to do your first titration. And then for your second titration, you guys are going to be doing that again in the lab, but it's super similar to this first titration. So the first thing that you need to do after creating your table is you need to obtain approximately 80 mils of potassium permanganate solution in a 100 ml beaker. Okay, so I've got about 80 mils right there. Notice it's purple. In 3, it says set up a clean 50 ml burette in a burette clamp on a support stand. So that's what you see right before you. Okay, that tool right there, that is a burette. Okay, this is a burette, and it's got measurements on it, which I'll show you in just 1 second. Okay, next it says rinse the burette with approximately 10 mils of distilled water, and then with 2 5 ml portions of potassium permanganate. So as I do this, I'm going to explain why I do it. Okay, so really quickly, notice that if the stopcock is parallel to the burette, that means that it's going to allow it to flow. So before I do this, I want to close it, and then I'm going to pour some water in. Now the reason why I'm doing that is because I want to rinse out the burette. I don't know what was in here before, so I'm going to turn this parallel and it's going to flow out. Okay, so I've got to wait for that to go through, and then I can continue. All right, then I'm going to add my potassium permanganate. Now the reason why I need to add a little bit of potassium permanganate is because if I add potassium permanganate right now and use that as my titrant, what will happen is that my solution will actually be diluted, and I don't want it to be diluted. So by adding 2 5 ml volumes of potassium permanganate, then I know that my solution is not diluted, that it has the same concentration as what I assumed its concentration was. All right, so this is steps that you have to complete before you ever start a titration. So it's going to be a little bit of waiting for this volume to go all the way down. So now I'm going to pour a little bit of potassium permanganate in there in order to make sure that my solution isn't too dilute. Okay, I'm going to turn the stopcock, and I'm going to allow all of that to flow through as well. Okay, so you can see that flowing into my beaker. Now keep in mind, whenever I'm doing this, I'm using a beaker because that's my universal trash can in chemistry. Now while that's going, I'm going to do my next step for the lab. I'm going to skip number 7, okay, and it says in 8, obtain a mass between 0.4 and 0.5 grams of ferrous ammonium sulfate in a clean weighing dish using a milligram balance. Record the precise mass in an appropriate data table. All right, so I'm going to show that right now. Okay, notice it says 0, but as soon as I add my weigh boat on it, the mass no longer is 0. So I've got to hit 0 here. Okay, and then I'm going to measure out between 0.5 and 0.6 grams of this substance. Okay, so now I've got that. Now that the solution, the potassium permanganate, has flowed out of that, and remember I'm going to do that washing twice where I add the potassium permanganate to make sure that my solution is not too dilute. Okay, now I'm going to close it, and I'm going to add potassium permanganate all the way to the top now. Okay, right until I hit 0. Okay. So you can see it's right at the top. Okay. The one thing I need to do, and look in the directions what it tells you to do, it says open the stop clock to allow any air bubbles to escape, close the stop clock when the liquid level is between 0 and 10 ml. So if you notice right now, at the very base of my burette, there's air, right? And so if I were measuring this, right, and I measured this volume right here, I'm assuming it's at this volume. Well, if there's air there, then I'm assuming is potassium permanganate, which it's not, it's air. So I've got to get rid of that air, allow it to drain a little bit. Now that the air is gone, now I can actually measure the volume. So if you look at the very top, okay, this reads like a ruler. So you start at 0. So the volume of this, remember you want to read the meniscus, the very bottom part, it's not going to be 3.2. It's going to be right at the meniscus. It's kind of hard to see, but right at 2.8, and that's my volume. So notice I'm reading from the top to the bottom. Okay, so it's going to be about 2.8 volume, so you would record that in your data table. In the next step, it says measure 10 mils of 3 molar sulfuric acid into a clean 10 mil graduated cylinder. Measure 10 mils of distilled water into a separate clean graduated cylinder. Add these in a 250 mil Erlenmeyer flask. So I'm going to do that right now. So I've got one graduated cylinder right here. That's a 10 mil. I'm going to pour 10 mils in. Now remember, for you need to put it on the table. Let me show you. You need to squat, make sure that you're eye level, and notice I'm not at 10 mils. And a great thing for you to use is just a pipette, okay? If the volume's getting kind of tricky to be able to get, because I want exactly 10. Okay, and I squat. And there we go. Okay, there's my volume. So I'm going to add that to my 250 mil Erlenmeyer flask. So I'm going to add that in. Okay. Then it tells me to get 10 mils of distilled water and do the same thing. So that's exactly what I'm going to do. Okay, and I think I got exactly, right at 10 mils. Okay. Okay, so now I'm going to swirl this, and then I'm going to add what you just found the mass of. I'm going to swirl that as well, let it dissolve. Okay, so then it says position the flask under the burette so that the tip of the burette is within the flask, far above the liquid. So it's going to look like that. You're going to put it right under there, make sure it doesn't touch, and there you go. All right, and you're actually going to be holding the flask in all likelihood. Titrate the ferrous ammonium sulfate solution with the permanganate solution until the first trace of pink color persists for 30 seconds. Remember to swirl the flask and rinse the walls of the flask with distilled water before the end point is reached. Remember to swirl the flask. Okay, so this is what it's going to look like. Okay, you're going to have it go parallel to the stopcock. You can allow it to have a steady stream at first and let it keep going with a steady stream until you start to see a little bit of pink linger, and then you want to add dropwise. Okay, so it could be going for a while. Keep swirling. So one person could be in charge of the stopcock, one person in charge of the swirling. I do it all myself, but make sure that everyone gets experience with this. Notice it's starting to linger a little bit, so I might add it a little bit slower. Okay. Okay, I'm gonna really try and do dropwise now. Whoop, whoop, whoop. See how quickly it changes? Okay, so I got that light pink color. I slightly overshot it. You want it as close to clear as possible and only a tiny hint of pink. Okay, so now I wanna measure the volume, so I would go here. I would look at where the volume is. Okay. And I would notice that's at 20, see where the meniscus is at, it's kind of hard to read, but I would say 20.8. So that would be my final volume. So you subtract a final minus initial, and you've got the volume that you used, the volume of potassium permanganate you used in order to titrate the ferrous ammonium sulfate. So now that you've determined the volume of potassium permanganate that was needed in order to reach your end point with the iron ions, you're going to complete this twice. You're going to get 2 different volumes of potassium permanganate, then you'll average them, and that will be the volume of potassium permanganate that you used. Then, using that volume of potassium permanganate and the information about the iron ions, you need to determine the concentration of potassium permanganate before you can move on. Okay, so you'll do that, and then you're going to determine the concentration of hydrogen peroxide. It is the exact same steps, and I'll show you that in 1 second. I'll re-explain really quickly. But before we can do that, you need to write out the full reaction between the potassium permanganate and hydrogen peroxide. So write out that full reaction, okay? And then finally, you're going to use the exact same steps that I just showed you for determining the concentration of potassium permanganate. Now you're going to do the exact same thing, except you're going to replace iron ions with the hydrogen peroxide, and now you're going to determine the concentration of the hydrogen peroxide.